Here's an example of how we can use our understanding of the non-speaking length tension and the tension band to develop a hammer technique that actually works. In our previous example, I tuned the C here using a go sharp, ease flat technique. Okay, so this note is now within a cent, and I could use the bend test or test blows. And it's gone flat a couple of cents. The analysis says that the non-speaking length tension was not left high, it was too low. So what happens is when you go sharp and you ease flat, because we're at 12 o'clock, there's no unbending, so it's all untwisting. You go sharp and you ease flat, the untwisting raises the tension, but not enough. What we want to do is get that non-speaking length tension to raise more. So we can't change the twisting. So we're going to have to change the unbending. And the only way you can change the unbending is by adding bending while you're tuning. So while we ease flat, we're going to be pressing down a little bit. So when we get to the target pitch and we let go of the hammer, it's going to untwist a tiny bit, but also bend back. And that's going to add more tension to the non-speaking length. So let's give it a shot here. I'm going to press down a bit while I ease it flat. There. Okay? Within a cent. On the negative side, maybe negative 0.5. And now. It looks like it's gone down less than a cent. If we wanted to make that better, we could just add a little bit more down bending. Now, also, we're talking about a long non-speaking length. So if you do a little research on Hooke's law, you'll realize that anything we do to the pin does not affect the tension as much in a long non-speaking length. On the shorter non-speaking lengths, this unbending and untwisting has a greater effect. That's Hooke's law. So that's why we've got to be a little bit more aggressive with the long non-speaking length using this technique. A stable pitch. Let me just show you another technique that I often use on the grand, especially when with a long non-speaking length. This is called slow pull. Now the reason why this works is because I pulled the pitch up and the non-speaking length is already at the top. Now I pulled it up, which means the pin is twisted clockwise and bent towards me during tuning. And after the tuning, the pin bends back, the pin untwists. Both of those things reduce the non-speaking length tension. This technique is frowned upon by many technicians because it does not leave the tuning pin set. The go sharp, ease flat technique is good because it leaves the tuning pin set in a counterclockwise position, and if you did a little bit of down bending, or if you had your hammer at a bit of a 3 o'clock or a 2 o'clock, then you are also bending the pin towards the string, so you're leaving the tuning pin set under the force of the string trying to bend the pin counterclockwise and bend it towards the string. So that's what the tension in the string is trying to do anyways. But when I use a 3 o'clock and pull like that, I'm leaving the pin unset. And that goes against what some techniques describe as you have to set the pin. So you tell me, how come this is stable? Why is it stable? The answer to that question has to do with the length of the non-speaking length. Because this is so long, yes, the untwisting, yes, the unbending lowers the non-speaking length tension, but because this is so long, the actual change in the tension is very small. On a short non-speaking length, this wouldn't work as well, because the non-speaking length tension would lower more during the unbending and the untwisting phase. But because we have a long non-speaking length, I bring it up to pitch, stop what I'm doing, and the unbending and the untwisting will lower the non-speaking length tension, but not a lot. The non-speaking length tension is still high in the tension band. And over time even, this pin may continue to unbend and untwist. But again, because it's a long non-speaking length, the tension will not reduce very much. The pin will unbend and untwist, but if it was a shorter non-speaking length, that same unbending and untwisting over time would result in a greater drop in the tension. So that's two techniques that have been derived from an understanding of the non-speaking length tension and the tension band.